We are taking R.D. Sharma Solutions, Class 10 Maths, Chapter 16, Exercise 16.2. Here we have a question in which we have a conical hole. We have a cylinder and there is a conical hole in this cylinder. The height is given as 12 centimeter and the base radius is 5 centimeters. So both of them will be having their base radius as 5 centimeter. The height and base radius of the cone are also same, that is given here. Find the whole surface and the volume of the remaining cylinder. That is, we'll try to find out the volume of the cylinder and subtract the volume of this cone, that will be the remaining cylinder. So here we have this as 5, the height is also given as 12. So we can find out the slant height of the cone. That is going to be 5 square plus 12 square under root. We are using the Pythagoras theorem. So L will be equal to under root 12 square plus 5 square under root 169. So the slant height would be 13 here. This will be slant height. Now what is the total surface area? Total surface area will be this one plus this one. Okay, this one plus this one, that is, what is the curved surface area of the cylinder? 2 pi r h. What is the base area of the cylinder? It is pi r square. And what is the curved surface area of the cone, which is actually the cut part of the cylinder? That is pi r l. So we just have to add these three. And we know the radius, now we know the slant height also. Just put in here, it will be 210 pi. Coming to the remaining part, we have to take the volume of the cylinder minus volume of the cone. Volume of the cylinder is what? Pi r square h. Volume of the cone will be 1 by 3 pi r square h. So pi you can take out, r is 5, h is 12. Here we have again r as 5 and h is 12 because they both share the same radius and height. It is going to come as 200 pi. A tent is in the form of a cylinder. We have a cylinder of diameter 20, so the radius will be 10. The height of 2.5, this is 2.5, surmounted by a cone of equal this base, that is the radius will be same, and the height is now 7.5. So the height of the cylinder is 2.5, height of the cone is 7.5. Find the capacity of the tent and the cost of canvas as well as the price of rupees 100 per this square meter. So here what we will do, capacity we have to find out. So first of all, this is the height 7.5 and this is the base which is 10. So we have to find out the slant height. So 10 square plus 7.5 whole square under root. This is going to be the slant height of this cone. What is the surface area of the cone? Pi into r into L. So pi is there, r is the radius 10 and L, which is the slant height, which is going to be 12.5 from here. And this is the surface area of the cone. And what is the volume of the cone? It is 1 by 3 pi r square h. R is 10, h is 7.5. So this is going to be 250 pi. Coming to the surface area of the cylindrical part, it will be 2 pi r h. Radius is 10, height is 2.5. The volume of the cylinder will be pi r square h. Pi into 10 into 10 into height is 2.5. The total capacity will be this capacity 255 plus this capacity, which is going to be this 255. So it is going to be 500 pi. And what is the total area of the canvas required? It will be simply the addition of the surface area of the cone and the surface area of the cylindrical part. So we just add them, it is going to be 550 meters square. So the total cost of canvas will be what? This is the meter square. This is the total surface area. So for 1 square meter it is 100. So 1 meter square it is 100. So for the 550 it will be 550 into 100 and this is going to be 55,000. Consider a boiler. This is a boiler, is in the form of a cylinder. So we have a cylinder here having the length 2 meter and there is a hemispherical end, each of having diameter 2 meter. This is diameter 2, this is diameter 2, this is 2 meter again. What we have to find the volume of the boiler. So we have to take this part and these two parts are exactly similar. So this is 2 by 3 pi r cube. The volume will be for this one, that is the first and second part is 2 by 3 pi r cube. So 2 by 3 pi r cube, 2 by 3 pi r cube, that is 4 by 3 pi r cube. And how about this cylindrical part? The cylindrical part is pi r square h. Pi and radius is what? See, this is the diameter is 2 from here to here. Radius will be 1. So radius for this one also will be 1 and this one will also be 1. So pi into r square into h. What is the height? The height for this one is 2 and height for this one is given as we don't need the height here. So this is going to be 220 by 21. This is the volume of the boiler. A vessel is a hollow cylinder. So this is a cylinder which is hollow, fitted with a hemispherical bottom of the same base. So this is the hemispherical bottom of the same base. The depth of the cylinder is 14 by 3. So from here to here it is 14 by 3. And the diameter of the hemisphere is 3.5. So diameter is 3.5. Just take it half. It will be 1.75. We have to calculate the volume and the internal surface area of the solid. So we'll take this part and this part, take the volume, add them. Also, the surface area of the hemisphere will take, and the surface area of the cylinder we are going to take. First of all, the radius, as I said, 3.5 by 2, because 3.5 is the diameter, it is going to be 1.75, and the height will be 14 by 3. So total volume will be the addition of the volume of these two. So this volume will be pi r square h, r will be 1.75, height is 14 by 3. And for this will be, this hemisphere, it will be 2 by 3 pi r cube. So 2 by 3 pi r cube, our radius we are going to take as again 1.75. Just add them, it is going to be 56.06. When it comes to internal surface area of the solid, it will be surface area of the hemisphere plus the surface area of the cylinder. That is, surface area of this part, that is the hemisphere part, is 2 pi r square. Surface area of this cylinder will be 2 pi r h. So just add them, because we know the radius is 3.5 by 2, 1.75, and height of the cylinder is 14 by 3. It is going to be 77 by 12. The calculation is in front of you. Consider a solid which is composed of a cylinder. This is a cylinder part, and with hemispherical end. So this is first part, this is second part, and these are the hemispherical end. The complete length of the solid is 104 meter. From here to here it is 104 meter, and the radius of each of the hemispherical end is 7 meters. So this is the 7 meter radius, and this is the 7 meter radius. And find the cost of polishing its surface at the rate of 10 per decimeter square, or 10 per decimeter square. We are going to change it into centimeter or meter square. Okay. Now, first of all, this part, what will be the height of the cylinder? This is total 104. This is 90. How? Because this part is 7, so we subtract this 7 part, and this is also 7, so we subtract this also. So 104 minus 14 is going to be 90. So 90 is the height of this cylinder. And what is the total surface area? It will be 2 pi r h for the cylindrical part, and the hemispherical part, it will be 2 pi r square. This will also be 2 pi r square, so total will be 4 pi r square. Height is now 90 for the cylinder h, and radius is, of course, both has same, so 7. So we just computed 4, 5, 6, 7, and this is 10 per decimeter square. You just have to convert it into because this is centimeter, so this 10 per decimeter square, and we have to convert it into the centimeter, so divide it by 100 and multiply it. It will be 457.60. A cylindrical vessel of diameter 14 centimeter and height 42 centimeter. So we have a cylindrical vessel. Let me make a cylindrical vessel. Now here the diameter is 14, so the radius will be 7, and height is 42. So 42 is the height. Is fixed symmetrically inside a similar vessel of diameter 16 centimeter and height 42 centimeters. So the height remains the same, but now there is one more cylinder. So this cylinder is having the diameter of 16, so the radius will be 8. From here to here it will be 8. The total space between the two vessels from here to here, means this space we are talking about, is filled with a cork dust for heat insulation purposes. Find how many cubic centimeters of cork dust will be required. So we need to find the volume of this region, actually, outer region. So we'll take the volume of the outside, we'll take the volume of the inside and just subtract. So the volume of any of the cylinder will be pi r square h. So this will be pi r2 square. This capital R is the outer one. Pi r square h minus pi small r square h. It will be pi into h and r square minus small r square. So what is the radius? As I said, the first radius, the outer radius is 8, inner radius is 7. So just put in here pi, height is 42, r2 square minus r1 square, that is 8 square minus 7 square. You compute it, it will be 1980 centimeter cube, right? A cylindrical road roller made up of iron 1 meter long. Its internal diameter is 54 centimeter and the thickness of the iron sheet used in making the roller is 9 centimeter. Find the mass of the road roller if 1 centimeter cube of the iron has 7.8 gram mass. So here we have a road roller. We assume it to be cylindrical size. Now the cylindrical road roller made up of iron is this much meter long, so it is 1 meter long. And since others are in centimeter, we will convert it into the centimeters. 1 meter is 1 into 100, that is 1 meter is 100 centimeters, so it will be 100 centimeter. So this will be 100 centimeter height. Then internal diameter is 54, so the internal radius will be what? Internal radius will be 54 by 2, that is 27. And the thickness of the iron is 9. So this thickness is this iron from here to here, it is 9. So what will be the outside radius? 27 plus 9. So the small r, that is internal radius, is 27. The capital R, that is the outer radius, will be 27 plus 9, because 27 is the internal radius and 9 is the thickness. So 27 plus 9 is going to be 36. So internal radius and external radius, what we have to do, we have to take the difference of the volume, that is pi r square h, outer one minus pi r square h, internal one pi into h, r square minus small r square, this r square, this is 36 and this is 27. Height is 100 centimeter, pi is 3.14. This will be the volume. Now 1 centimeter cube, the volume is 7.8 gram. So for this much centimeter cube, you just have to multiply this and this. So multiply these two, and now this comes in gram. Just put some, take it here, point here, it will be in, or you can say you divide it by 1000, so it will be in kg. So it will be 1388.7 kg, mass of the road roller. A vessel is in the form of a hollow cylinder. So this is a hollow cylinder, and mounted by a hollow hemisphere this is a hollow hemisphere and this is a hollow cylinder. The diameter of the hemisphere is 14 centimeters. So this is 14 centimeter diameter. So the radius will be 7, and the radius of the cylinder will also be 7. And the total height of the vessel is 13. So here to here it is 13. And this height, or you can say radius of the hemispherical part is 7. So what will be this height from here to here? It will be 13 minus 7, and that is going to be 6. So this is 6 centimeter. So the inner surface area of the vessel will be what? It will be this surface area plus this surface area. Surface area of the hemisphere is 2 pi r square, and surface area of this cylinder is 2 pi r h. And we know all the value. Radius is 7 for both, and height is 6, we just found out. And it is going to be 572 centimeters square. A toy is in the form of a cone. So here is a cone we have, and there we have a hemisphere. So the toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. So the total height of the toy from here to here, it is 15.5 centimeter total height. The total surface area has to be found out. Now this height is given as 15.5. This is the radius 3.5 and this is 3.5. So what will be the height here? 15.5 minus 3.5. So the height will be 15.5 minus 12.5. That is going to be 12 centimeter. This is the 12 centimeter height of the cone. Okay, and radius of the cone and radius of the hemisphere will be same. Now what we have to find out the total surface area of the toy. So it will be the curved surface area of the conical part and the surface area of this hemispherical part. And this, what is the conic, because slant height is already given, so we don't have to find out the, this L, it is already given as, okay. Now there is a change. I just need to change something here, because we need our L, and this L is nothing but the height we found out. So what we are going to do, this is 12 and this is 3.5. So we will find out this one, that is the slant height. So it will be, this will be 12 square plus 3.5 whole square. So this will be 144. And what is 3.5 whole square? Let me compute. 3.5 into 3.5. And this is going to be 12.25. We just have to add them. That is, you have to add plus 144. And this is going to be 156.25. And 156.25, let me just find out the 156, the root. Okay. So I'll just take the root of 156.25. That is going to be 12.5. So now here, this is not 12, this is 12.5. There is the only difference. So the answer will come as, it will be, 12 and 12.5 doesn't, there is no huge difference. So this 12.5 can be added to this 7, it will be 19.5. So just, I'll give you the exact answer now. Okay, so what we have to do here is, this is 3.14 into this 3.5, that is going to be 10.99 into 19.5 here. I hope you got the idea. So the answer will be 214.305. Okay, this is the answer, centimeter square. So the only difference is you have to take the slant height, because the total surface area, that is the curved surface area of the conical part, is pi r n. So this is one more part of this exercise, and we'll be taking one more of this. Till then, thank you so much and take care of yourself.